Now we are going to use this first question to discuss the concept of precision and accuracy. Now let's look at the question first. We are given that a student measures the length of a wire 4 times using a meter rule and obtain the following readings: 18.6, 18.5, 18.6, and again 18.5. Determine the length the student should record. This one is common. When you repeat a particular measurement more than once, you are likely to get different measurements. Why is this recommended? It is recommended because you're trying to reduce one of the errors that may affect your measurement. And one of those errors may be systematic error. We're going to study the idea of errors in this question. Let's first of all look at the answer. So we are going to add the 4 values and then divide by 4 in order to get the average. And then we are going to ask ourselves, what is the level of precision of a measuring of a meter rule? So I've already written down the answers in this slide. So you can see I've already obtained the average to be 18.55 centimeters, but the value the student should write should reflect the level of precision of that measuring instrument. So it should be 18.6. So you round up that value to 1 decimal point of a centimeter, because the meter rule should record, when you take measurements using a meter rule, your values should be recorded to 1 decimal point of a centimeter, not more than 1 decimal point and not less than 1 decimal point. For example, if you record that value as 19 centimeters, it is wrong. You have rounded up fine. If you record it as 18.60, that value will also be marked wrong because you have not observed the level of precision of a meter rule. I'm going to talk about accuracy and precision, and I'm going to use this question to do that. So let's look at the distinction between those two terms, accuracy and precision, because you can see I've used those two terms in our discussion here. So what is meant by accuracy? A value is said to be more accurate than another one if it is closer to the true value compared to the other one, which is not accurate. So accuracy is the degree to which a measurement approaches the true value. When we are measuring physical quantities in physics, and of course that is why the subject is called physics, we deal with physical quantities. It is so important to get the magnitude of physical quantities. What are these physical quantities? For example, you can be given a marble. A marble has got certain features which can be measured. For instance, you can measure its mass, you can measure its diameter. Those features of the marble which are measurable, its mass, its diameter, they are called physical quantities. And a physical quantity must have a number and a unit. The number and the unit, we call it magnitude. So in physics, we spend much time measuring magnitude of physical quantities. So the marble, for example, its diameter has got a particular value, which we can say it is the exact value. It is the true value, but we do not know how much it is. So we take a measuring instrument and try to measure the diameter. When we do that, due to the errors that maybe the measuring instrument might have, or the errors that we might introduce into the way we use the measuring instrument, our reading or our measured value will not be equal to the true value, to the exact value or to the exact diameter of the marble. It will be different. So the one measurement which is very close to the true value is said to be more accurate than the other measurements which are far from the true value. So by accuracy, we mean the degree to which a given measurement that we have taken approaches the exact value that we are trying to measure, or the exact magnitude of the physical quantity we are trying to measure. What are some of the factors which affect accuracy of a measurement? There are three of them. The equipment used. For example, when we are determining the diameter of the marble, we could decide to use a meter rule, or a vernier calipers, or a micrometer screw gauge. Those are different equipment or different pieces of apparatus. We could use each one of them with a different level of skill. So the level of skill matters here, or even the technique that we involve in determining that particular diameter. So these are three factors that are very important that affect the accuracy of the measured value. Now, when there is a difference between the true value and the measured physical quantity, we say our value is either accurate or inaccurate. So, and we might want to reduce the difference between the accurate value and our measured value. And therefore, we are trying to reduce something we refer to as error or uncertainty in a measurement. So the reduction of error or uncertainty in a measurement improves its accuracy. I've introduced another word here, uncertainty. First of all, let me say that when we use the word error in measurement of a physical quantity in physics, it does not mean that we have made a mistake. Every measured value has got a certain level of uncertainty. It cannot be exact. The only thing we can be sure of is that that value will lie between this value and this value. We can be sure that it can't go outside those brackets. For example, when we measure the diameter of a marble and we find it to be approximately 1.2, we can say if we're using a meter rule, then the value lies between 1.1 and 1.3. We are sure it cannot be smaller than 1.1 and it cannot be larger than 1.3. So the average of 1.1 and 1.2, 1.3 is exactly 1.2. So every measured value has got a certain level of doubt, or we are uncertain about that measurement. So nowadays we desist from using the word error, because when we talk about error, it gives the person who is reading that report that maybe a mistake has been done, which is not the case. So the term that we use nowadays is called uncertainty. So when we use the word error in our discussion here, it doesn't mean that a mistake has been done. Remember that. So how about precision? Precision is that part of accuracy which is within the control of the experimenter. You see, the experimenter could decide to use different measuring instruments and may use them with different levels of skill, depending on how skillful he or she is. The aspect of that measurement which will be affected is called precision. Let's take, for example, the example that I've already given, the measurement of the diameter of a marble using a meter rule, a vernier calipers, and a micrometer screw gauge. Maybe a meter rule gives us a reading of 1.2 plus or minus 0.1 centimeters. 0.1 centimeters is the least count on the scale of a meter rule. We count in steps of 0.1. It's possible to count in steps of 0.1. So that 0.1 centimeters there is the least count. When we use a vernier calipers, the least count is 0.01 centimeters. So we get a measurement of about 1.21 plus or minus 0.1. Let me just say this. that when we take a measurement of 1.21 plus or minus 0.01 centimeters, it means that the uncertainty lies in the last digit. We are sure that 1.2 is exact. That diameter cannot be greater than 1.3 or less than 1.1. We are exact. We are sure that of this digit here. We are sure of it. The only digit that we are not sure of is the third digit, the second decimal here. And you can see when we move from a meter rule to the vernier calipers, we have actually increased the number of significant figures. Here it is 2, here it is 3. Now we can measure the same diameter using a micrometer screw gauge and get 12.12 millimeters, because a micrometer screw gauge measures dimensions or its length in millimeters. And then for the sake of comparison, I have converted the millimeters into centimeters by dividing those millimeters by 10, because 10 millimeters make 1 centimeter. So 12.12 centimeters or millimeters will be 1.212. Observe that over here, we are sure about this digit here, this digit. Now we are uncertain about the fourth significant digit. You can see that here the number of significant figures now are 4. The level of precision increases as we move from the meter rule, vernier calipers to the micrometer screw gauge. In fact, the number of significant figures in a given measurement indicates the level of precision, while how close that measurement is to the true value or to the actual magnitude of the physical quantity we are measuring indicates its accuracy. Let's look at an example in order to emphasize this fact. Over here, I have this question here. You may pause the video and give me the answer. However, let's go on and look at the solution. We are given a series of measurements of the acceleration of free fall, g, and we know that the true value of the acceleration due to gravity or the acceleration of free fall close to the earth and along the equator is about 9.81 meters per second squared. That is the exact value. So this question assumes that you know the exact value of g on earth. The table shows the results obtained. Which student obtained a set of results that could be described as precise but not accurate? In terms of precision, given that the value of g is 9.81, you can see that all these digits, they are to 3 significant figures other than this one here. So this one is even more precise than the exact value of g. So, given that all the digits are to 3 significant figures, then you can see that they are precise. But when it comes to accuracy, we've got to look at this. We are asked to look for those which are not accurate. So we must know the true value of g. Remember, accuracy is the degree to which a measurement or a calculated value approaches the true value. So how far is, for example, 9.45 from the true value of 9.81? You can see it differs by about 0.35. Again, this one is also different from the value of g. This is 8.99. again far away from G. So when you have considered all these values, you will set off for a choice like student D. Look at the values, 8.45, while the true value is 9.81. Each one of them is 8 point something, 8 point something, 8 point something. That 8 point something is very far from 9.81, which is the true value of G. So you can see D, all the values, they are not accurate. But when you go to the other values over here, you will find that some of them are closer to the true value than others. So it is not all the values which are far from the true value. So when it comes to questions like these, then you will be able to see that D will be the best choice, because you can see they are very far away from 9.81, so they are inaccurate. They are not accurate. But when it comes to precision, they've got the same level of precision as the precision of G, which is 9.81. That is how we would answer that question, because it falls under accuracy and precision. So I hope the discussion has shed some light on the use of those two terms, accuracy and precision.